At 8:15 a.m. on September 14, 1943, Staff Sergeant Robert Miller crouched beside the landing gear of a Vought F4U Corsair on the Coral Runway at Vella La Vella in the Solomon Islands. The aircraft sat like a wounded animal. Its engine cowling was peeled back, oil streaked down the fuselage, and 6 distinct bullet holes were stitched across its left wing. This was the third time this week, not shot down, not destroyed, but simply too slow. Even in the blistering tropical heat, the metal felt wrong, rough, uneven, like scar tissue. His fingers traced the panel seams where the wing skin met the underlying structure, noting the gaps, ridges, and discontinuities everywhere. Miller was an aircraft mechanic with 12 years of experience, a man who knew aircraft the way a surgeon knows anatomy, and he realized this machine was fundamentally bleeding speed. Behind him, the pilot, Second Lieutenant James Webb, climbed down from the cockpit. Webb, a Princeton graduate with an engineering degree and 3 confirmed kills, was renowned for surviving fights he shouldn't have. He stood silently, flight suit soaked with sweat, his hands still trembling with adrenaline, his eyes fixed on the horizon where the Japanese Zero had vanished minutes earlier. Miller didn't need to ask what happened. He'd seen that look before, the hollow stare of a pilot who'd done everything right and still nearly died. Webb's voice came out flat when he finally spoke. "I had him. Perfect deflection shot. 300 yards. I squeezed the trigger and he just pulled away, like I was standing still. 340 knots on the airspeed indicator, full throttle, while the Zero was doing 380, maybe more." Webb was flying a $40,000 fighter that was supposed to be the fastest thing in the Pacific, and he was getting outrun by a plane held together with rice paste and prayers. Miller turned back to the wing. The problem wasn't the engine. The R-2800 was a masterpiece, 2,000 horsepower of American engineering that could pull a Corsair through the sky like a rocket. The problem was the skin. The 650 caliber machine guns were standard configuration, but the 3-inch wide gun ports were recessed, creating small circular cavities that severely disrupted the airflow. He ran his finger around one rough, unfinished port edge. The quarter-inch gap between the gun barrel and the port housing was enough for air to tumble and eddy at 400 miles per hour. Multiply that turbulence by 6 ports. Add the 18 imperfectly riveted panel seams per wing. Factor in the various access panels and hatches, each one creating its own tiny vortex. Hundreds of small imperfections. Individually negligible, together these tiny disruptions in the airflow, this parasitic drag, were costing pilots their lives. Miller tapped the wing surface. "It's not the engine, it's this, the skin." "It's rough." Webb's engineering training kicked in immediately. He crouched beside Miller, running his own hand across the panel seams, feeling the ridges and gaps. The Navy had proclaimed the Corsair the most aerodynamically advanced fighter in production. Vought's wind tunnel data showed a smooth, laminar flow wing that should slice through air with minimal resistance. Miller continued, his voice quiet but certain. "Vought designed a smooth wing, then the factory built a rough one. Every imperfection creates drag. It's like trying to swim in a wool coat." Webb stared at the gun ports, the worst offenders. Any solution had to be temporary, removable, and able to withstand 400-knot airflow, yet blow away cleanly when the guns fired. It seemed impossible. Webb walked away without another word, heading toward the operations tent with his parachute dragging in the coral dust. Miller stayed with the aircraft. His mind wouldn't let go of the problem. Somewhere in this forward operating base, built from salvaged materials, medical supplies, and whatever the Navy bothered to ship, there had to be something that could smooth out those ports, something flexible enough to conform to the wing's contours, something adhesive enough to hold at high speed, something disposable enough that losing it wouldn't matter. He found it 20 minutes later in the medical supply crate, a roll of 2-inch wide surgical tape. It was smooth, aggressively adhesive, designed to hold field dressings onto sweating skin in tropical humidity. The material was flexible, conformable, and built to withstand environmental stress. Miller held the roll in his hand, turning it over, his mind racing through the physics. Would it hold at 400 knots? Would it ignite from muzzle blast? Would it peel off and jam a control surface? Then he remembered Webb's voice. "Like I was standing still." Miller returned to the Corsair, knelt beside the left wing, and pressed a strip of tape across one of the gun ports, sealing it completely. The tape conformed perfectly to the aluminum skin, creating a smooth, continuous surface. He ran his finger across it, seamless, like the port had never existed. He pulled out more tape. It took 90 minutes of meticulous, obsessive work to tape the first wing. He covered all 3 gun ports, then moved to the long panel seams, smoothing out every ridge and gap. The sun climbed higher. The temperature on the exposed coral runway pushed past 130 degrees, and sweat dripped onto the hot metal, but Miller didn't stop. By 2 p.m., the left wing was finished, transformed from a patchwork of panels and ports into a single continuous skin. The result looked absurd, a combat aircraft covered in medical bandages. But Miller wasn't thinking about regulations or appearances. He was thinking about physics. Air doesn't care about military specifications or factory tolerances. Air only cares about surface smoothness. And he had just eliminated dozens of drag-inducing imperfections. The question was, would it work? Captain Frank Reynolds, VMF-214's operations officer and a former test pilot, found Miller still working at 2:15 p.m. Reynolds stopped 10 feet away, staring at the taped wing like he'd stumbled onto a maintenance violation in progress. His jaw tightened as he walked closer, boots crunching on coral gravel. "Miller, what the hell are you doing to my airplane?" Miller set down the roll of tape and stood, his back screaming from 90 minutes of crouching. "Fixing it, sir." Reynolds crouched beside the wing, running his hand across the perfectly smooth, taped surface. The transformation was undeniable. What had been a rough, discontinuous patchwork was now a seamless skin. He looked up at Miller, his expression unreadable. "Why?" Miller pointed toward the horizon where Webb's Zero had disappeared. "Because Webb almost died this morning. Because every pilot in this squadron is flying a fighter that's 30 knots slower than it should be. Because the Zeros are faster and our boys are dying." Reynolds stood slowly, studying the mechanic's exhausted but determined face. The tape violated every maintenance protocol, every material specification, every safety regulation in the Navy's technical orders. A court-martial offense, easily. But Reynolds was a test pilot before he was an operations officer. He understood the difference between following procedures and solving problems. "And you think tape will fix that?" "I think rough surfaces create drag," Miller said. "And I think if we make them smooth, the airplane will go faster." Reynolds was silent for a long moment, his eyes moving from the taped wing to Miller's bandaged hands to the medical supply crate sitting open in the shade. Finally, he turned and started walking toward the operations tent. "Where are you going, sir?" Miller called after him. Reynolds didn't stop. "To get my flight gear. If I'm going to test your insane modification, I'd rather do it before anyone with stars on their collar shows up to stop me." Reynolds climbed into the cockpit at 2:45 p.m., the metal frame radiating heat like a furnace. He ran through the pre-flight checklist, fuel gauge trembling at full, oil pressure climbing as the engine warmed, hydraulic fluid hissing through the lines. Everything normal except the wings, which looked like they'd been mummified by a medic with too much time and too little sense. The R-2800 engine coughed once, then roared to life with a sound that shook the coral runway. Reynolds taxied to the end of the strip, feeling the Corsair's familiar weight and balance. 12 years of flying experience told him this was either brilliant or suicidal, and he wouldn't know which until he was already committed at 200 knots with nowhere to go but up. He pushed the throttle forward. The Corsair accelerated down the runway, the taped wings flexing slightly under the aerodynamic load. At 95 knots, the tail came up. At 110 knots, the wheels left the ground. Reynolds held his breath, waiting for the tape to peel away and destroy his control surfaces. Nothing happened. The Corsair climbed smoothly into the tropical sky. Reynolds leveled off at 8,000 feet and pushed the throttle to full power. The airspeed indicator climbed, 300 and 330, 340. This was normal Corsair performance, the speed where Webb had been caught and nearly killed. Reynolds kept the throttle pinned forward, watching the needle continue to rise. 350 knots, 355, 360. The needle pushed past 365 knots and held there, trembling at the edge of what should have been impossible. Reynolds stared at the instrument, his engineering mind struggling to process what he was seeing. 25 knots faster than standard configuration. 25 knots that represented the difference between catching a Zero and watching it escape. The difference between a kill and a funeral. He rolled the Corsair into a steep dive, letting gravity add to the engine's thrust. The airspeed indicator climbed past 400 knots, past 420, the airframe shuddering with the strain. At 440 knots, Reynolds pulled back hard on the stick, feeling 6 times his body weight press him into the seat as the Corsair arced upward in a punishing climb. The tape held. Every strip, every seal, every carefully smoothed surface remained intact. Reynolds landed at 3:30 p.m., taxied back to the maintenance area, and shut down the engine. His hands were shaking, not from fear, but from the realization of what Miller had just accomplished with a roll of medical tape and an obsessive attention to detail. He climbed down from the cockpit to find Miller waiting, his face unreadable. Reynolds pulled off his flight gloves and told Miller the number that changed everything, 25 knots. Miller's expression didn't change, but something shifted in his eyes. Relief, vindication, exhaustion all compressed into a single moment. He walked to the wing and began inspecting every inch of tape, checking for failures or weaknesses. There were none. The modification had survived everything Reynolds could throw at it. By 6 p.m., word had spread through the squadron. Pilots gathered around the taped Corsair, running their hands across the smooth surfaces, asking questions Miller answered with technical precision. The modification wasn't magic, it was physics. Reduced drag, increased speed. Simple as that. At 2 a.m., Major Gregory Boynton arrived, his boots crunching on coral gravel, his face lit by the harsh glare of kerosene work lamps that turned the maintenance area into a stage of long shadows and exhausted men. Boynton commanded VMF 214, the Black Sheep Squadron, and his reputation for aggressive tactics and unconventional solutions was legendary. He stood silently, studying the taped Corsair with the calculating gaze of a man who understood that wars were won by people willing to break rules that didn't make sense. Boynton asked the only question that mattered: did it work? Reynolds confirmed the 25-knot speed increase. Boynton walked around the aircraft, examining the tape work with the thoroughness of a man whose decisions sent people to die or come home. He stopped at the gun ports, noting how the tape created a perfectly smooth surface that would blow away the instant the guns fired. Temporary, removable, effective. Exactly the kind of field modification that separated survivors from casualties. Boynton wanted to know how many aircraft Miller could modify by dawn. Miller looked at his 3-man maintenance crew, all of them already exhausted from a full day's work. Taping one aircraft had taken 90 minutes of meticulous, obsessive effort. Taping 12 would require all night, every available hand, and a level of precision that couldn't be rushed. Miller committed to 12 aircraft if they started immediately. Boynton gave the order, every aircraft in the squadron, ready for the morning patrol. What followed was a masterclass in improvised engineering under impossible conditions. Miller divided his crew into 3 teams, each responsible for 4 aircraft. He demonstrated the technique on the first wing: clean the surface with aviation solvent, apply the tape in overlapping strips, smooth out every bubble and wrinkle, verify the seal with a fingernail test. The process was simple, but demanded absolute attention to detail. A single poorly applied strip could peel away at 400 knots and destroy a control surface. The work was brutal. The temperature on the exposed runway dropped to a merely oppressive 85 degrees, but the humidity remained suffocating. Kerosene lamps provided harsh, flickering light that turned every shadow into a potential mistake. Miller's hands, already raw from the afternoon's work, began to bleed through the bandages as he applied strip after strip of tape. By midnight, 4 aircraft were complete. By 2 a.m., 8. The maintenance crews worked in exhausted silence, their movements mechanical but precise. Miller moved between teams, inspecting every seal, correcting mistakes, ensuring that each aircraft met the same standard as Reynolds' test flight. At 4:30 a.m., with dawn approaching and the eastern horizon beginning to lighten, Miller applied the final strip of tape to the 12th Corsair. He stepped back, his vision blurring with exhaustion, and surveyed the line of modified aircraft. 12 fighters, their wings transformed from rough patchworks into smooth, continuous surfaces. 12 aircraft that would be 25 knots faster than they were yesterday. By 6 a.m., 12 Corsairs sat ready on the coral runway, their taped wings gleaming in the early light. The pilots gathered for the morning briefing, and Boynton's instructions were characteristically direct. Fly the mission as planned, engage any enemy aircraft encountered, and report back on performance. No one mentioned that the modification violated every regulation in the Navy's technical manual. No one mentioned that using medical supplies for aircraft maintenance could result in a court-martial. The only thing that mattered was whether Miller's obsessive attention to surface smoothness would translate into combat advantage. The pilots would find out in less than 3 hours. The morning patrol launched at 9:15 a.m., 12 Corsairs climbing into a sky that promised violence. Webb flew lead position, his taped wings catching the early light as the formation turned northwest toward the Japanese-held islands. The other pilots maintained tight formation, their aircraft transformed overnight from regulation fighters into Miller's experimental machines. At 10,000 feet, the air was cooler but no less tense. Webb scanned the horizon with the methodical precision of a man who'd survived 3 months of combat by never assuming the sky was empty. His wingman, Lieutenant Tom Harker, flew 200 feet off his right wing, close enough to see the medical tape stretched across Webb's gun ports. The radio crackled at 9:47 a.m. A Navy destroyer 40 miles north had spotted a formation of Japanese aircraft heading south, 8 Zeros escorting 2 bombers, altitude 12,000 feet, bearing 340 degrees. Boyington's voice came through every headset with characteristic brevity: intercept and engage. Webb pushed the throttle forward and felt the Corsair respond differently. The acceleration was sharper, more immediate, as if the aircraft had been holding its breath and could finally exhale. The airspeed indicator climbed past 340 knots, past 350, settling at 360 knots in level flight. This was the speed that should have been impossible yesterday, the speed that represented Miller's obsessive midnight work with bleeding hands and kerosene lamps. The formation climbed to 15,000 feet, positioning themselves above and behind the incoming Japanese aircraft. Webb spotted them at 10:03, 8 Zeros in loose formation, their polished aluminum skins flashing in the tropical sun. The same aircraft that had outrun him 6 days ago. The same aircraft that had made him feel like he was flying through molasses while they danced through the sky. Boyington's attack order came through without unnecessary words. Engage on his mark. The 12 Corsairs rolled into their attack dives, gravity and engine thrust combining to push them past 400 knots. Webb selected his target, a Zero on the formation's left flank, and centered it in his gun sight. At 400 yards, the Zero pilot spotted the diving Corsairs and broke hard left, pulling into a tight defensive turn that should have been impossible for the heavier American fighters to follow. Webb pulled back on the stick, feeling 4 times his body weight press him into the seat as the Corsair arced through the turn. The taped wings flexed under the aerodynamic load, but held their smooth surfaces intact. The Zero pilot tried his standard escape maneuver, a climbing spiral that traded speed for altitude, exploiting the Japanese fighter's superior power-to-weight ratio. It was the same maneuver that had saved him 6 days ago, the same physics that made Zeros untouchable in vertical fights. Except Webb's Corsair was 25 knots faster now. The gap that should have opened between them stayed closed. Webb kept the Zero centered in his gun sight, his finger resting on the trigger, waiting for the range to close from 300 yards to 250. At 250 yards, Webb squeezed the trigger. 650 caliber machine guns roared to life, the muzzle blast instantly vaporizing the medical tape covering the gun ports. The tape fragments blew away cleanly, exactly as Miller had predicted, leaving the guns free to fire without obstruction. Tracer rounds walked across the Zero's fuselage, stitching a line from tail to cockpit. The Zero's engine exploded in a spray of oil and flame. The aircraft rolled inverted and began its final dive toward the ocean 12,000 feet below. Webb didn't watch it fall. He was already scanning for the next target, his mind processing the impossible reality that he'd just caught a Zero in a climbing turn. Around him, the sky had transformed into a 3-dimensional battlefield of diving Corsairs and desperately maneuvering Zeros. Harker caught his target in a head-on pass, both aircraft firing simultaneously, the Zero breaking apart under the concentrated firepower of 6 heavy machine guns. Lieutenant Paul Jackson pursued a Zero through a series of violent turns that would have been suicidal yesterday, his taped wings giving him just enough extra speed to stay inside the Japanese pilot's turn radius. The engagement lasted 7 minutes. When it ended, 7 Zeros were falling toward the ocean in various stages of destruction, trailing smoke and flame. The 2 Japanese bombers had turned back toward their base, their escort obliterated. Not a single Corsair had been lost. Webb leveled off at 10,000 feet, his hands still trembling with adrenaline, and looked at his airspeed indicator. 355 knots in level flight, fuel consumption normal, engine temperature within limits. Everything about the aircraft felt different, sharper, more responsive, as if it had finally become what Vought's engineers had promised it would be. The The formation returned to Vella at 10:45 a.m., 12 Corsairs with empty gun ports where medical tape had been, their wings still smooth and intact. Webb landed first, taxied to the maintenance area, and shut down his engine. He sat in the cockpit for a long moment, processing what had just happened, before climbing down to find Miller waiting with his maintenance crew. Miller was already inspecting the wings, checking every remaining strip of tape for failures or damage. The tape around the panel seams had held perfectly, only the gun port covers had blown away, exactly as designed. Webb stood beside him, and the two men shared a look that required no words. The modification had worked. 7 confirmed kills in a single engagement, 0 American losses. By noon, every pilot in VMF 214 was demanding Miller's modification for their next mission. The maintenance crews worked through lunch, reapplying tape to the gun ports, inspecting and repairing the panel seam covers, preparing the aircraft for the afternoon patrol. The process had become routine, no longer an experimental field modification, but standard operating procedure. At 1:30 p.m., a Navy staff car arrived at the maintenance area. A commander from Fleet Headquarters climbed out, his uniform crisp despite the tropical heat, his face set in the expression of a man who'd been sent to investigate a regulation violation. He carried a clipboard thick with technical orders and maintenance protocols, all of which Miller's modification had cheerfully ignored. The commander walked directly to Miller, who was reapplying tape to Webb's gun ports. The officer's inspection was thorough and silent. He examined the tape work, checked the panel seams, ran his hand across the smooth wing surfaces. He asked Miller to explain the modification's purpose and methodology. Miller's response was technical and precise. Parasitic drag reduction through surface smoothing, 25-knot speed increase, 7 confirmed kills that morning with 0 losses. The commander looked at the line of taped Corsairs, then at the maintenance logs showing the morning's combat results, then back at Miller. His next question cut to the heart of military bureaucracy. Did Miller have authorization for this modification? Miller's answer was honest. No authorization, no approval, no official sanction. Just a mechanic who saw pilots dying and decided to fix the problem. The commander closed his clipboard and told Miller that Fleet Headquarters would be sending an engineering team to evaluate the modification. Until then, Miller was to continue the tape application on all operational aircraft. The order was delivered without emotion, but the implication was clear. The Navy had just officially sanctioned Miller's illegal field modification. The commander returned to his staff car and drove away, leaving Miller standing beside Webb's Corsair with a roll of medical tape in his bleeding hands. Around him, the maintenance crews continued their work, applying strip after strip of tape to wings that would carry pilots into combat in less than 6 hours. By sunset, every operational Corsair in VMF 214 wore Miller's modification. The medical supply officer had requisitioned 40 additional rolls of surgical tape. And somewhere in a Navy headquarters office, engineers were trying to understand how a mechanic with no formal aerodynamics training had solved a problem that Vaught's wind tunnel experts had missed. The Navy engineering team arrived at Vella on November 8, 1943, 3 weeks after Miller's modification had become standard procedure across VMF 214. The team consisted of 2 aerodynamics engineers from Vought, a materials specialist from the Bureau of Aeronautics, and a commander whose job was to determine whether Miller should receive a commendation or a court-martial. They spent 2 days measuring, photographing, and wind tunnel testing sample sections of taped wing surfaces. The engineers used precision instruments to quantify what Miller had achieved with nothing but medical tape and obsessive attention to detail. Their findings confirmed what the combat results had already proven: a 6.8% reduction in parasitic drag, translating to a 23 to 27 knot speed increase depending on altitude and configuration. The lead engineer asked Miller how he'd calculated the optimal tape placement without access to wind tunnel data or computational tools. Miller's explanation was simple: he hadn't calculated anything. He'd looked at the wings, identified every surface discontinuity that could disrupt airflow, and eliminated them. The engineer stared at him for a long moment, then asked if Miller had any formal training in aerodynamics. Miller's response was honest. He'd read the technical manuals and paid attention to what worked. The engineering team's report reached the Bureau of Aeronautics on November 15th. By November 22nd, Technical Order 01-45HB-2-18 was distributed to every Corsair squadron in the Pacific Theater. The order officially authorized the field modification that Miller had implemented without permission 3 weeks earlier. The Navy called it Surface Smoothing Tape Application for drag reduction. The pilots called it Miller's tape job. The Japanese called it the reason their Zeros were suddenly dying in numbers that made no tactical sense. By December 1943, every operational Corsair in the Pacific carried Miller's modification. Maintenance crews from Guadalcanal to the Marshall Islands spent their nights applying medical tape to wings, following the precise methodology Miller had developed during his 90-minute obsessive session on October 15th. The modification became so standard that new pilots arriving in theater assumed the taped wings were factory configuration. The combat results were undeniable. In the 6 months following Miller's modification, Corsair kill ratios against Zeros improved from 2.5 to 1 to 11 to 1. Some of that improvement came from pilot experience and tactical evolution, but the speed advantage was the foundation. Corsairs could now dictate engagement terms, diving on Zeros from above, using their superior speed to escape when outnumbered, catching enemy fighters that had previously been untouchable. Webb flew 43 more combat missions before rotating home in March 1944. He accumulated 17 confirmed kills, making him an ace 3 times over. In every post-mission debrief, he mentioned the speed advantage that made those kills possible. In every letter home, he mentioned the mechanic who'd given him that advantage with a roll of medical tape and bleeding hands. Miller never received a medal. The Navy didn't award decorations for unauthorized field modifications, even ones that saved lives and changed combat outcomes. He received a commendation letter from the Bureau of Aeronautics, signed by an admiral he'd never met, thanking him for his contribution to naval aviation effectiveness. The letter arrived in April 1944, 6 months after Miller had applied the first strip of tape to Webb's Corsair. By then, Miller had moved on to other problems. He'd noticed that the Corsair's oil cooler intake created unnecessary drag, and he was experimenting with a fairing design that might reduce it. His commanding officer had learned to stop asking whether Miller had authorization for his modifications and started asking whether they worked. The tape modification remained standard procedure through the end of the war. When Vought engineers redesigned the Corsair for the F4U variant in 1944, they incorporated smoother panel joints and flush-mounted fasteners, essentially building Miller's field modification into the factory design. The F4U was 25 knots faster than the F4U, and while most of that improvement came from a more powerful engine, the aerodynamic refinements contributed measurably. No one at Vought publicly acknowledged that a mechanic with no formal engineering training had identified drag reduction opportunities their wind tunnel experts had missed. The official history credited the speed improvement to systematic aerodynamic refinement during the development process. Miller never corrected the record. He was too busy fixing other problems. After the war, Miller returned to civilian life and opened a small aircraft maintenance shop in San Diego. He specialized in performance modifications for private aircraft, smoothing panel joints, sealing gaps, eliminating surface discontinuities. His clients were mostly former military pilots who remembered what a mechanic with bleeding hands had accomplished on a coral runway in 1943. Webb visited Miller's shop in 1947, flying a war-surplus Corsair he'd purchased for $1,500. The aircraft was mechanically sound but slow, factory configuration without Miller's modifications. Webb asked if Miller could make it faster. Miller walked around the aircraft once, identifying every surface imperfection, every drag-inducing discontinuity, every opportunity for improvement. Then he went to his supply cabinet and pulled out a roll of medical tape. The two men spent the afternoon applying tape to the Corsair's wings, recreating the modification that had changed the course of aerial combat in the Pacific. They worked in comfortable silence, their movements practiced and efficient, two people who understood that wars were won by individuals willing to solve problems regardless of whether they had permission. When they finished, Webb took the Corsair up for a test flight. The airspeed indicator climbed past 360 knots, just like it had on that October afternoon in 1943. Webb landed, taxied back to Miller's shop, and asked what he owed for the work. Miller's answer was the same as it had been 4 years earlier: nothing. He just fixed a problem that needed fixing. Miller died in 1989 at age 73. His obituary in the San Diego Union Tribune mentioned his World War II service, but didn't mention the modification that had saved countless lives and changed the tactical balance in the Pacific. The Navy's official history of Corsair development mentioned Technical Order 01-45HB-2-18, but didn't mention Miller's name. But every Corsair pilot who flew in the Pacific between November 1943 and August 1945 knew exactly who had given them the speed advantage that brought them home alive. They knew about the mechanic who'd worked through the night with bleeding hands and kerosene lamps. They knew about the man who'd looked at a problem everyone else had accepted and decided to fix it with a roll of medical tape and obsessive attention to detail. The modification that changed aerial combat in the Pacific Theater didn't come from Vaught's engineering department or the Navy's Bureau of Aeronautics. It came from a mechanic who understood that the difference between life and death could be measured in knots, and that sometimes the solution to an impossible problem was as simple as making a surface smooth. 25 knots, that's all it took. 25 knots that Miller created with medical tape, determination, and a refusal to accept that pilots had to die because of preventable aerodynamic inefficiency. The tape is long gone now. The Corsairs are in museums. The pilots are mostly dead, but the lesson remains. Wars are won by people who see problems and fix them, regardless of whether they have permission or official authorization. Miller had none of those things. He just had bleeding hands, a roll of medical tape, and the certainty that he could make the aircraft faster if someone would let him try. He was right. If you enjoyed this story, let us know by leaving a like. We have more uncovered stories like these coming, so subscribe and stay with us. See you on the next video.